Y'all ready for this?
All right, y'all ready for this? Today's review is on piecewise functions. Let's talk about what is a piecewise function. All right, if you look at the graph is in pieces. In particular, this graph has two pieces. Okay, and they both happen to be linear pieces because they're both a line. One is this line going over this domain, which means all values less than 0. The top line is this one for all values greater than 0. Okay? And now what we're going to do is we're going to talk about how we evaluate a piecewise function and how we graph a piecewise function. So below I have 3 other examples of piecewise functions. Now the top 2 are not continuous. Why do you think they're not continuous? While the bottom one, if I had an arrow, would be continuous. So if you notice, the bottom ones are connected. The top 2, they don't connect. Okay, where you have to jump from one to another, that would be discrete, that would not be continuous. So let's talk about how do you evaluate. So a piecewise could have 1, 2, 3 different types of equations. And in this case, this piecewise has 2 equations. Okay? It gives you 2x plus 3 if x is less than 0. So what the heck does that mean? That means for all x's that are below 0, you would use that equation. We have x minus 5 if all x's are greater than or equal to 0. So 0 or above. Okay. So if I ask you f of negative 2, okay, usually that's f of x. So that means x is negative 2. So which equation do we use? 1, 2, the top, the bottom, right? X is negative 2. So this right here tells you which x values you're allowed to use for each equation. So negative 2 is below 0, so we're going to plug negative 2 into the top. Okay, and we're just going to evaluate, and we get negative 1. Okay. So f of negative 2 is negative 1. It tells you where to plug each value in. Okay? F of 4 means when x is 4. F of 1 means when x is 1. So that's what you're going to do for those 2 right there. All right, how to graph a piecewise. Just graph them one at a time. Okay, you graph the first one. This happens to be a line. X plus 6. So what I would suggest is you use pencil for this. Okay? If you want to graph it without a calculator, you can go to 6. Okay? And I'm going to go up one, right one, and I can't, so I'm going to go down. Okay? Now it says, so if I draw my line, it says for all values less than negative 2. So I go to negative 2 on my x. That's right here. Okay. So I don't actually want the values above it. I only want everything less than negative 2. Okay. Now I'm going to put an open circle on this value here because I do not want anything equal to it. So then I'm going to take it, I'm going to graph this one. Okay? So I'm going to go, what the heck's the b? I'm going to start at 0, down 2 right one, okay, up 2 left one, okay, and in this case it says above or equal to negative 2. So here's negative 2. So everything greater than it is to the right of it. And I colored this one in because it was or equal to. Now, you could definitely use your calculator. That may be a little bit easier for some of you. Okay, so I'll show you how you would do this if you used a calculator. So what you would do is you would put one equation in at a time. So I'd put x plus 6, go to my table, okay, and I want x is less than negative 2. So I'm going to want everything below negative 2. So I've got some values here. Of course, it's going to stop. Sorry. Ugh, this is annoying. Okay, all right. So let me start at negative 2. Okay, so I'm going to pick off a few values for that one. So I'm going to just graph a couple of them that are less than negative 2 and plot them on there, and that would give it to me. Then I would go and I would put in negative 2x, my table, and I wanted to pick everything that was greater than or equal to it. So then for that one, I would do negative 2 and above. I would plot some of those points, connect them with a line, and that is how I would get the graph. And that may be a little bit easier, okay, to kind of understand what's going on. So now we're going to have you practice with a group.